In this video, you're going to learn how to shift functions. We're mainly going to focus on quadratic functions. Those are our powers of 2, like x squared will be in them. And we are going to be shifting left, right, up, and down, and you're going to notice what happens to the graph and what happens to the equation. So please make sure you have your heading on your paper. Just a little note before we start with shifting. In order to graph functions, there's a few ways you can do it algebraically and graphically. For the purpose of the beginning of the notes, we're going to stick with using a graphing calculator. So your first note, can you write use a graphing calculator? Use a graphing calculator. So what we're going to do is type in the equation, and then we're going to look at our table. To figure out the correct points to use, we're going to center our table. So can you write center your table? Center your table. And I'll explain what that means in a minute. We're going to be centering it so that way your vertex is in the middle of your table. So in parentheses, can you write put vertex in the center? Put vertex in the center. And once we start graphing with our calculator, you'll see what I mean by that. Your vertex will automatically be in the center. So what we're going to do is we're going to graph 4 sketches of some graphs and see what happens when we're shifting left, right, up, and down, and what happens to the graph and what happens to the equation. So can you write for the directions? Sketch each quadratic function. Sketch each quadratic function. And state the vertex. And state the vertex. So we're going to be making graphs on this note sheet. We're not going to need graph paper for this. We're just going to make sketches, but you will need it in the future. So here's our first example. Can you write y equals x squared? This is what all of our graphs will be based on today. So I'm going to make an x and y axis. So again, we're making a sketch. So just make it as best as possible. And I'm going to grab my calculator to make sure I'm doing it right. So I'm going to go to y equals, and I'm going to type in x squared. I can take a look at my graph to see what it should look like. So if I look at my graph, it looks like a parabola, U-shape, and it looks like it's going to the vertex, or the origin. I want to make sure though. So I'm going to go to my table, and I'm going to center it. And what I mean by centering is, I need the top and the bottom y to match. So it was where it should have been, but I wanted you to see the difference. I'm going to keep moving this until the top and the bottom y's match. You notice I have a 9 and a 9 on the top and the bottom. That is a centered table. If you notice, our vertex will be in the middle. So if I was really graphing this, which you don't have to do, we would have -3, 9 over here, -2, 4, -1, 1, 0, 0. And then as we go up, we would have the points that would be symmetric. So we're not going to plot points today. Really what we care about is the vertex. So please graph the vertex for me, which is our 0, 0. And then I just want you to make a sketch of it by just making a U shape. So something like this. And it doesn't have to be perfect. There's our parabola. Our vertex was right in the center, which was 0, 0. So can you write vertex? And we're going to write 0, 0. Make sure you put that point in parentheses. So now let's see what happens when we add 2 to this equation. So I'm going to have you write example B, and I'm going to have you write y equals, and in parentheses, x plus 2, and then squared on the outside. So we're going to make a graph of this. So let me make my little x and y axis. I wonder what's going to happen to it. Here's my x and y. So here was my original graph. I'm going to go to y equals, and I'm going to type in parentheses x plus 2 squared. And I'm just going to hit graph just to see what it's going to look like before I graph the vertex. So if I hit graph, notice that this is what it was originally, and now the vertex appears to have moved over to the left. So I want to know exactly what that is. So I'm going to go to my table, and I'm going to center my table, which means I'm going to move this table so that way the top and the bottom lines match. 1 and 25 don't match. 4, 16 don't match. 9 and 9 match. There is my center table. So in the middle, you will notice that is my vertex, negative 2, 0. So I'm going to plot the point at negative 2, 0. There's my vertex. And now I'm going to make my parabola come from that point. My vertex, I'm going to state underneath. So vertex, that was negative 2, 0. So I want you to notice, when we added 2 inside the parentheses, notice the function shifted 2 units to the left. I'm going to have you point that out for me. I'm going to point to this little +2 and write shifts 2 units left. That will always work. Whenever you add 2 to the inside of the function, you're going to be shifting to the left. I want you to notice if I was to subtract 2, which we won't do on our paper, but I want you to notice what happens. Our graph would then shift 2 units to the right. So adding inside the parentheses is going to shift it left and right. Now let's do another one. Here's example C. Can you write y equals x squared minus 3? We're going to go ahead and make our x and y axis and see what happens when I subtract 3 at the end of the function. So here, x and y. I'm going to grab my calculator, go to y equals and type in x squared minus 3. And as you can clearly see, it's very important to have a graphing calculator. If I hit graph just to see what happens, remember this is what it was. Notice now it is shifted down. I wonder how many units. Well, let me grab my table. So second graph, I'm going to move my table. I'm going to center it so the top and the bottom y's match. So if I keep moving it, notice now I have 6 and 6. My vertex will be directly in the middle. That's 0, negative 3. So 1, 2, 3. So I'm going to go down 3 points. That's my vertex. My parabola is going to come from that point. So underneath, I'm going to write my vertex. So vertex, 0, negative 3. So if you notice, it's the same number as the end of the equation, negative 3. When we're shifting left and right, it's the opposite. So we would have, when we're adding 2 inside, notice the vertex starts with negative 2. Could you write for me? I'm going to point to this minus 3 and write shifts 3 units down. 3 units down. Can you guess what's going to happen if I did y squared or y equals x squared plus 3? You probably can guess that it's going to shift up, and it would shift up 3 units. Last one, example D. Can you write y equals x plus 2 squared minus 3? You probably can guess what's happening without even looking at our calculator. The x plus 2, this plus 2 inside is making it shift 2 units to the left. This minus 3 at the end is making the function shift 3 units down. So I'm going to go ahead and make my sketch, and we'll check it on our graphing calculator just to make sure. Let's give an x and y here. So my vertex is going to shift. This plus 2 means 2 units to the left, so 1, 2, and 3 units down, 1, 2, 3. So our vertex will be right there. Before I draw it, I better check just to make sure. So we'll go to y equals, we get x plus 2 squared, and then plus, oops, minus 3. I hit graph, let's see if it worked. Looks like it shifted 2 units to the left and 3 units down. I'll check my table really quick. There's my center table, and my vertex, notice, negative 2, negative 3. So I'm going to go ahead and make my sketch. I'm going to write my vertex. My vertex is negative 2, negative 3. 2, negative 3. And just quickly, I'm going to point to these 2 numbers. So shifts, this plus 2 means it shifts 2 units left. And this minus 3 means 3 units down. So I want you to notice the number in the inside is making it shift left and right, opposite of what you would think. Plus means it's going to the left, subtraction means it's going to the right. The number on the outside is telling you if it's shifting up or down. Minus means it's going down, and plus means it's going up. So now we're going to write those rules out so we have them. We take this off. Hopefully you guys had enough time to copy this down. Here are our rules. Can you write rules for changing, rules for changing y equals x squared to, and here's our rules. So we're going to have 4 of them. So 1, y equals, can you write x plus h squared? This h is just a different, just any number. If you are adding inside of the parentheses, the shift is going to be to the left. So can you write shifts left? Number 2, if we have y equals x minus h squared, that means you're subtracting in the inside. You can probably guess you're shifting to the right. So can you write shifts right? Shifts right. The third rule, if you have y equals x squared, but then you're adding something at the end, so plus k, we're going to call it k. If you're adding, that means you're shifting up. So can you write shifts up? For number 4, can you write y equals x squared minus k? So if you subtract a number at the end, that means you're shifting down. So can you write? These same rules apply to any function. So if you have a function, f of x, I'm going to put f of x right up here. So can you write f of x? If we were changing f of x to f of x plus h, same shift, shifting to the left. If you have a function and you subtract h, so you're doing f of x minus h, which means you're taking away a number from the x, you're shifting to the right. You'll see these examples in a minute. If you have a function f of x and you want to subtract a number at the end, so I wrote f of x minus k, or sorry, plus k, that means you're shifting up. And if you have a function f of x and you want to subtract a number from it, you're going to be moving the function down. And you'll see those examples in a second. So these are the rules for shifting. So now we're going to talk about equations. So can you write equations of shifted functions? Equations of shifted functions. You've seen what happens when you have it in vertex form. I'll cover this up for a second. When we're shifting to the left, you're adding 2 to the x. When you're shifting to the right, you subtract, and so on. You're using the rules that we have here to change the equation. You might have to simplify the equation, so we're going to do some examples of that. So can you write, for example, E, if f of x equals x squared? Write the equation. Of the new function, and we're going to write it 2 ways. We're going to write it in standard form and we're going to write it in vertex form. So here's our, I'm going to skip a couple of spaces. You'll see why. I'm going to have number 1 here. I'm going to put vertex form here, and standard form is going to go over here. And I'll explain the 2 just so you have them for your notes. So vertex form is when it looks like this equation, where we have a parentheses x minus h squared plus k, meaning you have a perfect square and then you have something added at the end. Usually we don't have a number in the front, but we will eventually as the course goes on. Standard form is when you get rid of the parentheses and you have it look like this: ax squared plus bx plus c. So we're going to take our equation, first write it in vertex form, and then change it to standard form if needed. So for number 1, can you write shifts 4 units up? Shifts 4 units up. So we are going to take this function and we are going to shift it 4 units up. So what we're going to do is we have f of x equals x squared. I'm just going to write y equals. That means the same thing. If we were going to shift this 4 units up, if you look up here, if we're shifting it 4 units up, we're adding the number to the outside. So instead of just x squared, it's going to be x squared plus 4. Standard form would be if we had to get rid of the parentheses, and we would make it look like this. There is no parentheses, so the answer would be the same. So you can just write same. You'll see as we get through a few that they'll be changed. Example 2. Can you write shifts 4 units down? Shifts 4 units down. So what we're trying to do is come up with a new equation given the shift, given the translation. So I'm going to start with y equals. If I'm shifting down, if I look over here, shifting down means I am subtracting a number at the end of the function. So I'm going to take my x squared and just put minus 4 instead. So there's my equation. Standard form would mean to get rid of the parentheses and simplify, and there's nothing I can do, so that would be the same answer. Example 3. Can you write shifts 4 units left? Shifts 4 units left. So remember, if you look up at the top, if we are shifting to the left, you are adding the number to the inside. So our equation was f of x equals, but we can stick with y equals. Instead of x squared, remember we're going to be adding the number inside. We want to shift 4 units left, so we're going to do x plus 4 inside the parentheses and then squared. Now standard form means we're going to get rid of the parentheses. So what I can do is I'm going to get rid of the parentheses by distributing. This x plus 4 squared means x plus 4 times x plus 4. So if I was to do the boxes, x plus 4, you don't have to do this, I'm just showing you. If I simplified all of that, I would get x squared plus 8x plus 16. So our standard form would be y equals x squared plus 8x plus 16. Number 4, you probably can guess it. We did 4 units up, 4 units down, 4 units left. Now we're going to try shifts 4 units right. Shifts 4 units right. Well, if you look up at the key, let's see, 4 units to the right means we're subtracting inside the parentheses. So we have y equals, instead of x plus 4, it's going to be x minus 4 squared. So there's your equation in vertex form. And by the way, this plus k at the end is just an imaginary 0. You just plus 0. So if I was to get rid of the parentheses, I'll do this really quick. If we did x minus 4 times x minus 4 into the boxes, we would get x squared minus 8x plus 16. You can always try that on your own. So our equation in standard form would be x squared, minus 8x plus 16. Notice I made a mistake, so I crossed it out and wrote it next to it. I did not try to write it on top. The last part of the notes is I'm going to give you the shift, and then we're going to be changing the equation, so a little bit different. So I'm going to take these off. I'll leave my rules nearby. Last part, this is example F. Can you write if f of x equals x squared plus 2x minus 5. So this time I'm giving you a different kind of an equation. It's still quadratic. Write the equation of the new function, and I'm going to write in standard form. because we're going to specifically get rid of all the parentheses. So I have 4 examples here. So I'm going to have example 1, 2, leave some space, 3, and 4. We are going to be shifting it left, right, up, and down. So for number 1, we're going to do f of x minus 2. Notice the minus 2 is at the end. This means we're going to take the function and subtract 2 at the end. For number 2, we're going to do f of x plus 2. We're going to see what the new equation is going to look like. For number 3, we're going to do f of x minus 2. X minus 2 is inside. And for number 4, we're going to do f of x plus 2. So what we're doing is we are taking our function, and just so you know, for number 1, minus 2 means we're subtracting 2, we're shifting it 2 units down. That's not that important for the equation part. Just know that when we have f of x minus 2, we're going to take our f of x function, which is this, to rewrite it, we're going to write that, and then we're going to subtract 2 at the end. So we're going to have, let me bring this down. We have x squared plus 2x minus 5. There's my f of x function. That matches this. Then I'm going to subtract 2 at the end. My new equation is going to be this simplified. So we're going to have f of x minus 2 equals. So I just brought this down. Now I'm going to simplify this. So we bring down the x squared. I bring down the plus 2x. And I bring down negative 2. Negative 5 minus 2 is minus 7. There's my new equation. So all we're doing is taking our original function and just doing whatever it says at the end. Number 2, this time we want to take the f of x function, but then add 2 at the end. So we're going to bring down our x squared plus 2x minus 5. That's our f of x function. And then the directions say to add 2 at the end. The last step is just to simplify. So I'm going to rewrite the beginning. So f of x plus 2. Now I'm going to combine like terms. So I have x squared plus 2x. Negative 5 plus 2 is a negative 3. So my new equation would be x squared plus 2x minus 3. The next ones are a little bit more difficult. This time, if you look, we want to do f of x minus 2. So we're going to take every x and change it to x minus 2. So a little more complicated. So I'm going to take this right here. Instead of x squared, I'm going to write x minus 2 squared. Instead of plus 2 times x, I'm going to put plus 2 times x minus 2. And then I bring down the minus 5. Let me explain that again. If you see a number inside the parentheses with the x, that is what you're replacing the x with. So for every x in this function, notice we change it to x minus 2. So instead of x squared, x minus 2 squared. Instead of plus 2 times x, plus 2 times x minus 2. And then minus 5. What we're going to do is simplify this. We have to get rid of the parentheses. So this would be the same as x minus 2 times x minus 2. If I was to do the boxes, I would get x squared minus 4x plus 4. And by the boxes, I mean these, where you have x minus 2 times x minus 2. And then you would simplify. So I've just changed this to this. Now I'm going to bring down this. I'm going to distribute. Positive 2 times x is positive 2x. Positive 2 times negative 2 is minus 4. And then I have this minus 5. Almost done. The last step is to combine like terms. So let me bring down the original name of the function, so f of x minus 2. By the way, this means we shifted 2 units to the right. Our new equation, let's see, we have an x squared. I can combine my negative 4 plus 2. That becomes minus 2, so minus 2x. I can combine my constants. We have 4 minus 4, that's 0. Minus 5 is minus 5. So there's our new equation. So again, if it's on the outside, it's really nice. You just bring that number at the end and simplify. So minus 2, we're at the end, plus 2, we're at the end. If it's in the inside, we are changing the x to all of that. So for number 4, we see f of x plus 2. This means we're shifting 2 units to the left, but we want to know the equation. So we are going to take this original equation and we are going to change every x to x plus 2. So instead of x squared, it's x plus 2 squared. Instead of plus 2 times x, it's plus 2 times x plus 2. And then I still bring down the minus 5. Now I need to simplify this. So remember, this means that I want to write it twice, so it means x plus 2 times x plus 2. If I was to do the boxes or distribute, this would become x squared plus 4x plus 4. So I just changed this to this. Now I'm going to distribute my 2. So positive 2 times x is plus 2x. Positive 2 times 2 is positive 4. And then I have a minus 5. Last step is to rewrite it and combine like terms. So I'm going to bring down my new function name, so f of x plus 2. And I'm going to combine like terms. So we have x squared. By combining the x's, we get plus 6x. And if I combine my constants, 4 plus 4 is 8. 8 minus 5 is a positive 3, so I have plus 3. There's my new function. So the main point of the notes, know that when you're adding and subtracting inside the parentheses, you're shifting left and right. If you are adding and subtracting on the outside of the function, you're shifting up and down. That applies for when you see the f of x. When you're changing equations, same thing. If it's at the end, you just put it at the end. If it's next to the x, you are changing the x to what's in parentheses. Please make sure you send a copy of the notes into Canvas to get credit for this assignment.